Good afternoon, everyone. My name is Shailendra Floria. I will be your moderator for this session. It is a matter of extreme privilege and honor for me to be sitting with such knowledgeable panelists and in front of such informed audience. The title of this panel discussion is Securing Critical National Infrastructure. These are big words, and the term critical national infrastructure is often confused because it does not really have a very well-defined set definition globally. Now, there are countries like the UK which have explicitly defined around 11 sectors which they identify as critical national infrastructure. That includes roads, transportation, banking and finance, telecommunications, energy, so on and so forth. But in most parts of the world, there is no clear definition of what exactly CNI is. I remember in India a couple of years ago, we were trying to identify critical information infrastructure. If some of you were part of the first CXO panel discussion, there was a lot of debate around what CII actually is. So what we thought in this panel discussion, what we will do is, we will pick a small section, a small component of the CNI, typically industrial automation and control systems. And instead of focusing on the entire bigger problem space of securing critical national infrastructure, we will sort of look at a smaller subset of the bigger problem space and focus ourselves on the industrial automation and control systems. Now, for those who are not aware of what exactly industrial automation and control system is, you could imagine things like oil and gas industry, electricity generation, transmission, distribution, and then a bunch of process control industries like your chemical factories, your cement factories, and so on and so forth. So this discussion is coming from that kind of background, because a lot of this forms the backbone of critical national infrastructure. And in this panel discussion, we will be looking at technology issues as well as policy issues. It's a wonderful experience that we have panelists from multiple experiences. We have Dr. Rahul Tongia from the academia and policy side. Professor Tongia taught at Carnegie Mellon University for a long time. Now he's an adjunct professor there. He's also led several policy initiatives and government initiatives for the government of India. We have Mr. Sarangpani from NTPC. NTPC, as you all know, is the largest power producer in the country. They generate about 25 billion units of electricity every month. So Mr. Sarangpani takes care of cybersecurity at NTPC. We have representation from the vendor community. Mike is the Vice President of Cybersecurity from Schneider Electric. And we also have representation from the independent researchers and consultant perspective, Justin, who is also a trainer at SANS. So we will start this discussion and we'll try to keep it more informal. So my first question would be, how do you think the industrial automation and control system security in general has sort of evolved in the past 1 decade or so? Because I think it was about 2007, 2008, we sort of started this initiative. So from your perspective, Justin, how do you see, as an outsider, the overall landscape of cybersecurity in this domain emerging?
I think over the last 10 years, we've actually seen a lot of emphasis. Before 10 years ago, a lot of companies that were running...
Sorry, can you bring it closer? Yeah.
Okay, I wasn't loud enough still, huh? Okay. All right, so I think over the last 10 years, there's been quite a bit of work done. I think that over the last 10 years, vendors that are creating products are for the first time actually including security and cybersecurity as design specs and requirements, and hiring very large teams, trying to go through and identify the security flaws. I think also the asset owners, the electric utilities, the oil companies, the gas companies, they're also starting to see the risks that are being portrayed, because they're seeing a lot of compromises, and they're hearing about a lot of their peer organizations being compromised. And so there's a lot of interest there, and also I think interest in the governments as well, because we're seeing regulatory requirements come down for cybersecurity for the first time in the last 10 years that we've ever had inside of critical infrastructure. So I think we're making good progress, but we also inherently have some issues that we have to deal with just how fast we can actually move. and how much infrastructure we have out there that has long life cycles. So we still have a long road ahead of us.
So sometimes when I look at this industry, I mean, it is a bit frustrating at times to see that some of the issues we were discussing in 2008, 2009 are still being discussed. Do you also have the same view in some cases, or do you have a different experience on that?
No, I think that's pretty common in general for cybersecurity everywhere. We are still discussing the same exact issues in IT security for the last 10 years and still dealing with the same problems. So I don't think it's something unique to critical infrastructure. I think it's something that is a permanent part of cybersecurity, period. Yeah. All industries.
I have a slightly different perspective as far as this second question is concerned. This cybersecurity thing, of course, in the control system has started, as you told, about 6, 7. But, in NTPC, we have traveled a good amount of distance, actually. In fact, it started slightly before that. It was a unit where there was a demand for seeing the data from the DCS to the corporate center. And, in those days, the people were not even aware of a firewall. Okay, so just, they connected the server directly to the corporate center without even a firewall in place, directly using the internet. And what happened? The result was predictable. The Morphe virus came and the server was shut down and the unit was off. So first realization, came long back, 13 years back. And from there itself, we thought that, yeah, this is important. This is something which has to be cared. It's not an IT thing. It has to be done. And then a consultant was hired. Specifications were made in those directions. And 3 directions work was done. One was about the security policies and guidelines, which has to be followed. The second was the security architecture. And architecture is such an important, it's just, even though today, in some ways I do agree with you, in the control and instrumentation industry, if you talk of cybersecurity, is only one word, which is say put a firewall. So it is very highly oversimplified in case of control and instrumentation field. But then the firewall and then so many things, the segmentation, the zone segmentation, the demilitarized zone, not sending data directly to a IT system through a buffering, and then having redundancy in the firewalls, then having the intrusion protection systems, 2 layer of different make so that you get a defensive. So a defense in depth architecture was involved. And that architecture was such that almost many layers of security were embedded actually. So that it becomes difficult for this thing, for the hacker to come into the system. And the third important part is the compliance. How the security audit, a system of security audit was started in NTPC in 2008 in the specifications. It was started with site and later it was done in the factory test. And the factory test was that the system will not be dispatched unless it is security compliant. And through a certain certified auditor, it has to be audited, vulnerability assessment, penetration testing, and many tests. It's getting evolved. There were so many things which were not there. Today, MAC-based testing, also filtering we have put. So it has evolved over the years. But when you say, is the progress satisfactory? No. Still, I think a lot more needs to be done. From that perspective, I'm 100% in agreement with you. But there is a long journey. I mean, it's a long distance which has been traveled. And because of this experience, NTPC was put on as a member for the IEC 62443 2-4 standard, which is basically control solution for the, specifically for the intelligent control systems. And there, NTPC had contributed to the development of that standard also because of this experience. And what we found was there was a big sync between the specification requirements and the standard in the beginning, at the draft stage, and then it was involved. So when you say but involvement, definitely a lot of things have been involved. But as far as the state of, in general, of the cybersecurity in the industrial automation system is concerned, yes, a lot more to be done, as you said.
Yeah.
Just an observation. We mentioned we're still looking at what was being talked of some years ago. There's more work to be done, you mentioned. I think that's actually a positive sign because there's been a recognition, at least in this space, which took a while in the smart grid space, for example, that this is a process. It's not a product. In the smart grid space, people said, you do this, you buy this, you put this in, and then you've become smart. And they expect the same thing. You buy the firewall, you buy some boxes, you put in some code or whatever, and now you are secure. But security isn't an R, it's not a state. It's actually an ongoing thing. And I think that realization's probably been the biggest change that I've seen, especially from a sort of big users in the industrial public sector, this sort of space.
So just to make a couple of points from the vendor perspective, if we go back more than a dozen years, I would say we actually devolved on security at first. With a mad rush to go to Ethernet and connect everything to Ethernet, security was never taken into account in those early days. And since then, now we've been ramping back up. So before those were totally isolated, disconnected industrial control system, industrial protocol systems with no connectivity to the internet, into the enterprise networks, etc. So we actually created more of a problem more than a dozen years ago, and then Stuxnet hit and people started waking up. That's when we really started to see that start to ramp back up again. But what you need to remember, speaking as a vendor, we are trying to meet the needs of our customers. If you don't value it, we're not going to do it. So if cybersecurity is important to you, then you need to tell us so. You need to make it a priority because we're here to serve your needs. If you let your salespeople know that our salespeople that are talking to you, then it'll help us to ramp up on security even more.
Well, we're not allowed to sell a car without a seatbelt, even though that seatbelt costs a little more money than a car without a seatbelt, or now airbags. And so at some point you may need a regulation. Yes, regulation.
And as a differentiator, and I think, again, people value it because they value the safety of their families, right?
Yeah, I have a take on that cost part. See, during the IUC discussions, there was a term which IUC standardization discussions at Poland. All were talking about a term called security fit for purpose. When you talk of national critical infrastructure, securing them, and when you say that security has to be fit for purpose, I mean, you do a risk assessment and then do basically the cost, this thing. I'm of the opinion that when you talk of the security hardware, software, the process, the audit, the actual cost is peanuts compared to the actual critical infrastructure which we are trying to protect.
Sure.
So in case of national critical infrastructure, the risk assessment and the cost angle actually takes a down seat, actually. Is whatever it's to be done to make the system secure, whatever available technology is there, and that has to be put. The problem lies in the awareness.
Yeah. So I think what you're trying to imply, and that is also a discussion we had last evening, was perhaps the only way of doing a threat assessment is looking at only the impact metrics rather than looking at many other things, which we are doing right now.
Yes.
Yeah. Moving on to a slightly different aspect. Now, of course, there are technical issues and there are regulatory and policy issues on why industrial automation and control system security is a difficult problem. So I wanted to get your insights onto some of the technical challenges you feel are present, and from a policy side as well. So Justin, would you be able to give some points?
Always have to start with me, huh? So some of the challenges that are present right now. So I think the biggest challenge right now is simply actually, number one, hiring people, and number two, to work on these cybersecurity challenges, and number two, trying to find the experience or the people with the right experience, or train the people with to have that right experience to be able to fill those jobs. We know how to secure a machine. We know how to make a machine hardened and resistant to attack. The problem is inside of industrial control system organizations, we don't have the manpower to do it. We haven't hired the teams to do it. We haven't trained appropriately the teams to be able to perform their jobs. And that's all a prerequisite before we can even start the problem. We often go through and say, well, the biggest reason why we don't do this is because we can't touch these machines because we have, so much sensitivity on the machines. And there's definitely some truth to that. However, I have never seen an organization that doesn't have a large percentage that they can touch, that they have touched and done it the right way. So we need people. I think that's the biggest challenge.
Right. So from Mike, from your perspective, what do you see as your biggest technical or a policy challenge towards securing the infrastructure?
Well, going back to the keynote this morning, I think it's more than just securing and hardening the solution. The solution, speccing in a product that from a vendor saying you must have a hardened product, because you've got to put the onus on them to also ensure that the components that they're using in their products have also been hardened, and that's a large technical challenge, I think, from a vendor point of view. And another context that Justin touched on is, for the longest time, the IT portion of a company and the facility management portion of a company, they did not get along. We'll put it mild. That's putting it mildly. They wanted nothing to do with each other. There was a lot of infighting. So anything that where they needed to get support from IT, they weren't getting it. They didn't trust IT. We're starting to see that come together a little bit more now. But to Justin's point, IT needs to understand what they can touch and what they can't touch. And getting to that point is still a great challenge. But at least we are seeing the facility side of the house and the IT side of the house start to talk and try to work together.
And really, I mean, to that lines, really what we really need is in the ICS OT side of the house, we need our own cybersecurity experts. We need our own cybersecurity team that's not part of IT enterprise. It's a different team, different reporting infrastructure. We need to have people that have that experience, at least on the asset owner sides.
Yeah, I think that one of the problems is people keep talking about the merging of IT and OT, and they don't really understand what that means, and they read a lot into it. And I completely agree. It needs to be a separate team. They coordinate with IT, but they've got to know what's going on inside that IT world. There's no merging that there's one IT OT organization that really serves it all. I think that would be a mistake.
From a technical perspective, do you also see some of the technologies that we are using in your IT SOCs, for example, some of those technologies like SIMs and other such things coming into the OT side as well and doing, because I think some companies like Indigi from Israel, so some of these companies are bringing out products which are tuned to the OT kind of technologies, doing an IT kind of function.
Well, I think we were talking about this a little bit last night. It's not so much like we putting TPMs into the products, so to protect the secrets in those. That's coming together. It's not that much of a challenge, other than the real challenge is on the supply chain side of how you load those secrets into those products in a secure manner. What's the other real pain is many of these systems are isolated. We're trying to use IT technologies like certificates in those systems, and now you've got isolated systems without access to certificate authorities on the internet, so you've got to create an infrastructure internally to support that. That is itself another complicated technology from a design standpoint of the products, of the system, and for the installers, and for the people owning the system that then have to maintain the security long term.
So there are actually, if you talk of this ISS, there are almost about, I should say, 4 or 5 critical points which distinguishes between the IT and the ISS security. First is we must understand that ISS security, especially the national critical infrastructure, is affecting the HSE, health, safety and the environment. Whereas a typical IT, I'm not saying that it doesn't affect, but a typical IT is more about the continuity of business operations. So the fundamentally both are, the impact point is different. Number 2 is that the ISS security is more difficult because the systems are more or less proprietary. If you relatively compare the IT systems and the industrial control systems, though there are a lot of openness, connectivity coming over the years actually, but primarily, if you talk of the Japanese system, especially I should say, there are a lot of proprietary protocols. So even if you want to, in the case of one system, we did the security audit, we wanted to have a separate port in the firewall for the inside zone, which is the control system zone, and the outside IT. So what was happening is we were not able to get what is the port of that Japanese DCS on which the communication goes. Then only I can filter on that port in the firewall. We are not able to get even the port number. So please try to understand that there's a lot of difference in the proprietary protocols, whereas IT is more or less very, very open. Number two. Number three is very important that the level of awareness in IT security among the IT people with security and the level is not the same. Typically, control instrumentation engineers are experts in their own fields in the process. And that makes it quite of a difference. In many installations, they leave it to the IT because they feel, that this is not our area. So you please go into that. And the fourth or most important thing is that when you represent before the regulatory authorities, this level of awareness, what Justin told, that they are separate, the team should be separate. But in NTPC, we are separate. In fact, we are quite self-sufficient in cyber security in our own domain from the instrumentation. But if you talk from the regulatory perspective, they consider from organization standpoint only one. For example, even in NTPC, you say, if you talk of CERT, the CERT representative who is to answer to all the regulatory authorities is the IT guy, And IT has to ask, okay, what is happening in your, there's no direct connection for the IT as well as your C&I team, the automation team separately. Even though teams inside may be separate, but from the regulatory perspective, it is single. So there are a lot of issues, there's a lot of fundamental differences between that.
So I want to second Justin's point about manpower and mindset. So to manpower, I will add mindset as another sort of fundamental challenge for this space. NTPC's, I think, Maharatna, it's a positive outlier in the public sector space. So the first sort of stepping up, I work in the policy space, so I sometimes take a less technical view. But in India, most of the a lot of the industrial space is more public sector than it is in the rest of the world. And as soon as you get out of few positive outliers like NTPC, the human capacity to deal with this is so limited that they hear the phrase Internet of Things. Yes, yes, yes. No, no, no. They get excited by its value and then scared saying, no, it's a bad, unsafe sort of thing. But the reality is it can be whatever we design it to be. So what they end up doing is two things. One, they outsource. So disproportionately compared to the rest of the world, this is that in-house ability question. They will go to technology service providers and say, you go run my system, which is good for the IT side of it, but that IT side doesn't talk enough to the OT side. The second thing that ends up happening is, in terms of a design perspective, they look at silos or segments. So the most common thing you'll hear for cybersecurity when you talk to not the technical people, oh, don't worry, our system is safe because I'm encrypting. And it's not just 112-bit, it's 256-bit, 512-bit, as if that solves this sort of a problem. And so what they're really asking for from the vendor is, I want a stamp of approval, that this stuff is safe, without realizing what is their ability to actually say, what does safe mean? Now this comes back at a higher level of critical infrastructure. What does it mean to be unsafe? Is it that you take down the infrastructure? Or is it just that you cause damage, which is at some level just impacts the monetary or outage level? So looking at the power grid, which is more some of my area, if I knock down one of his power plants, that would not necessarily bring down the Indian grid, but it would certainly cause them a lot of grief and some localized grief. So the question is, which are we worrying about more and why? And I don't think people have had that conversation, that how do we treat the interaction between narrow, rational, profit-making or private sort of incentives of what components of the system look like. Because the subtle point is, these are often cyber-physical systems. If you just say, I'm securing the cyber, your physical is going to take you down. And if you just secure your physical, your cyber is going to be your weak link. In the power sector, the most frightening attack, a lot of you may have heard of the Aurora project, where they ramped down up the turbines. How many of you have heard of the Metcalfe substation? So this was believed to be the first coordinated physical cyber link at a substation, large substation level attack in the US. And they thought it was just a probing attack. where after cutting out the IT, that was one part of it where they knew exactly what to cut off where. Snipers, which were probably military or ex-military trained snipers, 4 minutes fired over 100 shells at large-sized transformers, and your thermal imaging, your thermal sensors weren't able to signal that, hey, I'm getting too hot. Why? Well, because all my oil is bled out, because some guy with a gun took out that sort of a system. So that risk of cyber-physical is this double-edged sword. The more we use IT, the more sophisticated, advanced, and equilibrium our systems can get. We can run them not at 80%, but at 99%, which is part of the premise of IT. The more you do that, the more fragile you also risk making your systems. That one little thing can also cascade across.
I think there is also the issue of two different kinds of industries which bring in different kind of philosophies now colliding. On one hand, you have the control systems world, which has typically emerged from a very analysis first kind of principles, very solid engineering principles, where you do a design for Six Sigma, design for reliability kind of a philosophy. And on the other hand, you have software which typically, I mean, it was acceptable to ship it on Tuesday and get it right by version 3. And suddenly you have these two industries coming together and creating a lot of challenges. We did touch upon some of the technical challenges. I wanted to direct the next question to Mike. Most of...
We work for competitors. I think he's trying to give me hard questions.
I just complained, so.
Yeah.
But we are friends. So I know that most vendors are trying to set up some kind of an internal security program practice in place. So I wanted to get your views on what typically is this program and how effective do you think it has been in the last 10 years or so?
Sure. So we, as in many vendors, have been applying a secure development lifecycle. People have different flavors of it they're putting in place, but essentially they all cover starting with making sure your team has the proper training to know what they're doing, identifying security requirements, beginning the design, doing secure architecture reviews, threat modeling, going into implementation, performing static code analysis, performing penetration testing, other security testing while the development's going on, getting into the final security test, as well as properly documenting how to securely deploy the product, with the idea that these products should be, not always, but should be secure by design, secure by default, secure when deployed. And I use the term secure loosely because it's there's no absolute when it comes to security. So I often use hardened or resilient rather than secure. But that's really only part of the story. When really, if we want to be effective, what we've got to look at is the entire process from conception through manufacturing, through deployment, the distribution, through the installation, and then ongoing commissioning of the system. And going back to the earlier conversation, that we need the policies on how to properly do our system operations in a secure manner. We've got to be able to deploy those. In order to do that, we have to have properly trained people, knowledgeable people, and that's an area that we're very weak today. But we've got to look, if we really want to be effective, SDL through the design cycle is not enough. We've got to look through it through the entire life cycle of the product to deliver.
And I think the challenge there is that the life cycle of these products is typically like decades. So from an attention perspective, it's very critical that we have that span of attention through that entire life cycle, because otherwise it doesn't really solve the problem.
Well, that's absolutely correct. Our products generally are in use for 15, 20 years, and we build rock solid products. So and it's hard to look to the future and know what's going to happen. We can look to say, oh, quantum computing is going to be coming along one day, and it's going to obsolete everything that we're doing. Difficult to design around that, and the only option really for the vendors, for the end users then, is to replace those devices with something that's more up to date, or harden it outside of the device, using defense in depth techniques. But we have that same problem today because we developed a lot of progress. We have a huge installed base of legacy systems, and what we've got to do is come up with the ability to harden those legacy systems while incorporating newer products that have more security features and capabilities. So,
right. So, Justin, from your perspective, do you see the effort that the vendors are putting into the SDL program? Do you really see that effort having real effect on the ground?
Definitely so. I think across the boards, when you look at the large vendors that are out there, the companies that have gone through and actually hired the teams, done the training, testing their gear, accepting vulnerabilities, fixing the vulnerabilities, pushing out patches, even though many of the customers aren't deploying the patches. It's like 3 to 5% actually even downloads the patch, and we have no clue how many actually really install it. But no, we definitely see the efforts that are coming through. We're seeing the latest products that are actually coming on. You can actually Nmap scan them, and they don't fall over. So, that in of itself is a measurement. It's not a good measurement, but it is a measurement. But no, they really are secure. We see the vendors actively participating in all the standards work, in all the IEC work groups that are actually out there, anywhere from 62443, that's the security standards, all the way into all the new protocols that are actually coming with security extensions. I mean, authentication for control protocols and cryptography and payload signing. The vendors are very actively involved with this. They are actively deploying these new protocols on their systems in their test labs when they're available, and when standards are ratified, they're selling them to customers. So I think the vendors are making a lot of headway on their new products. I think they're still short on manpower, and it's a challenge because we always have bureaucracy and cost of doing business compared to what the vendor or what the customers are really buying. But I see great progress made in the new products. Old products, we're really trying to simply harden our networks to the point where they can't touch them, because you can't really upgrade old products to make them secure if they don't have the capabilities.
Isolate them.
Yeah, we're doing the best we possibly can, trying to build good security architectures.
I'll come to you. So Justin mentioned about standards and regulations. So from a policy perspective, what do you see as some of the initiatives that can be taken at that level to sort of alleviate this problem?
So I promise you I'm not looking at cricket scores. These are my notes. Policy is something that can go either way, because the wrong policy can hurt. And people have joked that the IT industry in India had a laissez-faire attitude from the government, is why it thrived. So where I think have a benefit and a push is needed, one is on I'll do it when it's important enough, picking up on Mike's point. And if we say that there's certain types of liability, that creates a financial incentive. So it's a regulatory hook, not by thou must do X, but you figure out what X is. I care about Z, which is the end result of the protection and the liability. I don't want to sort of pick the winners or the technology or the specifics of you must use this protocol or this anything. So I think that's one way policy can help. Second, I think we need to improve incentives and coordination for R&D and education. We don't have nearly enough interaction between the people who learn design, coding, IT, OT, all of these, and especially at a design architectural level as opposed to the lower end coding. This is a general sort of IT level complaint, but it extends in spades to the cybersecurity sort of a world from an Indian perspective. And last, I think we need to improve mechanisms to improve the life cycle, the speed at which we can resolve problems, because the instinctual reaction is hide, suppress, security by obscurity sort of a model, which is doesn't make sense. One challenge that the US has faced, and I don't know the Indian perspective as well, are you even allowed to test certain things and disclose them as a security researcher? Because you may be violating DRM laws. So DMCA, section 1201, for example. How many of you are familiar with these sorts of issues? A few are, but I mean, so what happened was there's a IT-based act on not cybersecurity, on sort of digital rights and encryption. You can't break someone's encryption. That was the law. It was an anti-piracy act. So your DVDs were protected, for example, what was the theory. Now, it became morphed because at the OT side, not the IT side, the laws were never meant to be competitive restricting or constraining R&D. So if I have an inkjet printer, they were not allowed to stop me from using a competitor's ink in an inkjet printer. The physical side wouldn't be allowed to stop you. But as soon as they put a software wrapper on it and said, I've got an encryption, and to talk to my printer, you have to break the encryption, you are now violating the law. If we think this is a problem with little sensors or these things, there's whole ranges of spaces. And the one I worry about the most is automobiles, because it may not be national critical infrastructure, but in terms of human lives and impact, that's a very big risk area.
Right. Moving on to the next point of discussion. So we are sort of concluding this discussion now. We started off by discussing what happened in the last 10 years, and then we sort of want to conclude by identifying what will perhaps happen in the next 5 years. I remember my PhD supervisor used to say that good research comes from real problems. So what are those real problems that the security industry in this space generally should be concerned about or should be addressing today, so that we solve tomorrow's problems? Maybe from Mike, any insights from you?
Well, first of all, I think just looking to the future, we're going to continue to see what's going on in OT, to follow what's happening in technology. So we're going to start. That's really the source of IoT. We've been doing IoT for years, but it's just been in larger devices. Now these so much sensors connected directly to Wi-Fi or Zigbee so much. And what's happened is with the advances in technology, we've been able to shrink that down, lower the consumption of energy required for these devices, so that we can push them out of the field and tie them back into the system overall. I think we're going to be seeing a lot more of that, and as we do, we're going to see our security challenges continue to increase as well, especially because so many IoT vendors out there are in such a rush to get to market that, again, security is the last thing on their mind. But so I think we're going to see a lot of that. I think we're also going to see a lot more in terms of advances of, again, technology allowing us to push security capabilities and features further down into our products. My big concern, and I mentioned it earlier, is something like quantum computing, something coming along that breaks the mechanisms that we have today and opens us up to attack, because everything we have in place is no longer relevant for securing us. And sooner or later, I think what we have today will be broken. So what can we do to we're going to have to be looking for solutions for that as we move forward.
Right. Justin, you would like to add anything?
Yeah, I have to stay positive and think that we as a human society here on Earth, we're going to eventually figure out this problem. So eventually, yes, I do believe that we're eventually going to find that right balance to adding benefit by adding technology and adding risk by balancing what's appropriate to the risk that we can really take on. Unfortunately, I think for the next 10, 15 years, I don't see much improvement there. I think we're going to continue to see attacks, and I don't think we've seen anything close to what we're going to see over the next 15 years. If we look at just simply from a level of risk and what we've done inside of Smart Grid with trying to add new functionality and new capabilities inside of Smart Grid, for those that don't know what a Smart Grid is for an electric grid, in summary, it really is the ability to take our existing control system protocols and add additional capabilities and features that we hadn't seen before, as well as adding new systems that are in there, which ultimately means that we are increasing dependencies and automation across the whole board. So attacks are going to have greater cascading effects in the future as we continue to do this. We're seeing the same thing in manufacturing with our manufacturing lines trying to actually become more real-time, more responsive to needs for the organization. We're seeing the same thing in oil and gas as well. So we'll eventually get there. But until then, we're keep on moving forward.
Yeah, a couple of points. Just want to just continue with that. One is that there are 2-3 trends which are coming out very clearly. One is the smart grid, as you tell, because India is going a very big way with smart grid. And smart grid being, it's not in isolation because it's at the electricity at where you purchase. I mean, it's on your house actually. So once anything comes into public domain, any public areas actually, not in isolated areas like our critical infrastructure, the security will be very real. So cyber threats will be there, and the security aspect will gain more prominence over the next 4-5 years because of smart grid and also the new technologies which will be there. One is the IoT. The IoT, especially when you talk industrial IoT, if I talk, then it's definitely going to enter the power industry as well as the process industry also in a big way. So when you have got IoT devices in the field, so you will have the cybersecurity concerns and the cybersecurity measures still more prominence. And the third and most important thing is that the world is going for remote operations. So today your remote sites are basically the young generation. They are not, interested in going to the remote places where the critical infrastructures will be located. And sooner or later, there will be concept of remote operations. So there will be some operation centers at center managing the various aspects, the efficiency aspect, the performance aspect, remote monitoring. So the data from the sites will be coming to the critical infrastructure to central place. So the more you use remote operations, the cyber security concerns are more. For its PGCL is doing all its operations from its Manesar center, substations. All substations in India are operated from that. So once you have a remote coverage, that increases the cyber security threat. So these are the technology trends which basically will evolve a path. And from 5 years from now, this will be, we won't be talking of so much as a grudge, maybe.
So, unfortunately, I agree with Justin's view that we may be setting ourselves up for something bigger than what we've seen before. And one of the reasons is complexity. What you had to worry about systems with hundreds or thousands of nodes is much larger, but more than larger, it's more opaque than it ever was. If you remember the stories about aircraft systems that have problems, because that one little box was with a piece of code written in the 1970s in Fortran that no one ever really understood what it did. You've got these sorts of vulnerabilities. I think one positive thing that can help against this is a lot more simulation and scale testing. Your ability to do testing now is far greater than it ever was. And I think that, if done well, can help us. It won't solve this problem, but it's another area that I think within the next 5, 10, 15 years will grow, especially as we add not just automation, but AI sorts of capabilities towards agent-based systems to these controls.
We have time for a couple of questions. It would be good if you could direct your question to the right panelist.
Hello everyone, my name is Sultan. I'm from Robert Bosch. I'm from cybersecurity. So I have a question for Mr. Shangarapani. So I believe that the current awareness in Indian government security is more of IT security, and as you said, the CERT is more interested in IT environment. And do you believe that there's a pressure from, let's say, public companies like NTPC to the government to come up with their own OT standards, security standards?
Yeah. Already, we have approached by India Smart Grid Forum to make a power system cyber security manual specific to India on the lines of NERC as well as IEC, of which I was a member. So we have contributed to that. It is in the draft stage, and it's basically in the in the process of formation. So that will be a specific. But my take on this is that unless you have an ICS cert on the lines of US in India, this process is, there will be difficulties in taking this process up because ultimately, if you, as I told, once again I repeat it for the sake of repetition, this is a very important point. Any response to the government agencies, even for the critical infrastructure, is done by the IT department. So, so it's not a grudge, but this is the process actually. So unless that process is a direct link, so it need not be a bypass route. This should be a straight route directly to the ministry from that. So this is very important that a need is felt among all and NTPC has been trying to push actually for an ICS cert. Number two, the audit agencies, which is being deployed by, is notified by the government, certified. This needs to be specific for the industrial control systems, because IT testing and industrial control systems are not same. So definitely there's a push, for that, on that side. Yes.
Thank you.
Just one.
My question is to Mike. Do you see a future? So Mr. Sarangpani mentioned sometime back around having more open softwares as compared to control systems where designs are more proprietary. Do you see that really, if more vendors such as yourself go in for more open designs, make their protocols public, do you see that solving issues in the future?
Yeah. No. Oh, yeah. No, it's okay. You're very enthusiastic. No, the first part I will just want to clarify that basically, that when I told that's proprietary systems, the issues regarding proprietary systems, I was mentioning the difference, how IACS security is difficult from that point of view. Of course, I don't advocate that you have to necessarily go for open system from the cyber security point of view. It's not a necessity, but what I'm mentioning the difficulty only. That's right.
So, and I also think there are two parts to your question. One was about the software, and one was more about the protocols. And for the most part, the protocols being used today are open to a point. All right, but then every vendor wants and needs the ability to differentiate by putting in their little spin on top of this. So they're open to a certain level. We're trying to drive interoperability between systems, and I think that's going to continue, and we'll open those up more and more. On the software side, I think there's also a trend to more of an open software approach. A lot more open source is being incorporated into the products that we provide today. So, and I think that will continue, because we're being driven, just like every other company, is to cut costs. And one way to do that is to utilize more open software platforms to develop on.
Any more questions?
We have just time for one last question.
Hi. So my question is, as most of our ICS systems and various SCADA systems are basically highly isolated from the internet systems.
Can you hold the microphone very close?
Yeah. So now, are you reading? Yeah. So the thing is, most of our ICS systems and SCADA systems are highly isolated, and they are not anywhere connected to the internet. But during the accounting period, they are being connected to various accounting systems or data aggregation systems, which are directly connected to various ERPs or SAPs. So this is the various highly attack vector for hackers to manipulate SCADA systems. So can you put a light on this thing?
Who do you want to answer that? Who do you want to answer that? Me? Okay, I'll go. Well, first of all, I don't believe there's such thing as a truly isolated system, because somebody is going to have a need somewhere, and the next thing you know, it's going to get connected up, and that's the worst case situation. So unless it's really a very, very well controlled government situation. But if we need to get the information out of those quote isolated systems into the enterprise side, and you've got a couple of options. Obviously, the more traditional DMZ type of approach, where you put the information in and you limit the direction, or you could use a data diode to pull information out one way from the isolated side to the enterprise side, and maintain that isolation in that way. Does that answer your question?
So I agree with Mike's point that there's a bit of a myth that you've got perfect air gaps everywhere. Second, I think some of us here are old enough to remember when in the world of connectivity. At one point, 80% of traffic was within the LAN and very little crossed outside the enterprise, and then flipped as the internet grew. So the question is there a world where we still have the protocols of IoT used in a more controlled and isolated environment? That comes back to a fundamental design question on how much are you going to utilize things that give you scale or interconnectivity. For his power plants, there is some value. If you're in a remote oil and gas rig, a lot of the things you need could be isolated if, now here's the $1 million if, you design it to have local intelligence storage, all of the steps, all of those, whatever you mean by local. I don't mean
well, even in that situation, you'll never be able to isolate. You know, I think I may have a unique perspective or unique view for everybody on the panel, because my job is to actually go into these underbellies and the cobweb covered areas that we all forget about that's inside of our architectures. And in truth, if you look at a control system, 99.999% of every control system is somehow connected back to the enterprise. Why? Because these enterprises, an electric utility, they exist to make money. They're selling power to people, and they can't sell power to people unless they know how much power they're generating, how much power they're distributing, and how much power they're actually feeding to your homes and to your businesses. And that's what the control systems do, is they provide that information, they provide that feature set. So they have to be connected some way, shape, or form. So yeah, there's no way we're going to get away from that. I mean, they're businesses that we're dealing with here. So we're not going to be able to isolate them. Even in the case where we could isolate, you're still going to have an operator there on site that can call and tell or something. We've worked on one where we had a drilling station in the ocean that we wanted to do 100% isolation with. And the best that we could possibly do is we put up a data diode. Unidirectional gate would probably be a better term for it. But to be able to take the data from that area and push it back. But how do you have a vendor that needs to be able to support the equipment on that remote oil shore? Well, what we did, VNC screenshots of the screen that's actually being pushed out unidirectionally back to the vendor. And if the vendor needs to fix something, the vendor can go ahead and call up the station, and an operator can sit there and over the phone basically be instructed what to click on, where to click on, and the vendor can sit there and watch the screen. But even in that case, that's not isolation. It's just a unidirectional stream of data out to be able to feed back into the enterprise with nothing coming back in. And that's where we're striving to go. That's what we're trying to do. But that's not isolation. And anytime I have a customer tell me that, yes, we're isolated, this is an isolated location, my first question is, well, when something goes wrong, how do your engineers get back in? Oh, well, we VPN in back in. That's not isolation.
Just one
and
last
there's a
word.
human involved there as well.
Yeah. No, just one last word to your question, actually. If you want a real perfect isolation, there are methods in IoT where if you want to send the data for remote support, then you cannot have isolation, as you told. But if you want to send data to a particular remote center, and if you have IoT devices in place, then what is happen? You can channelize it, which means suppose there's a HART protocol. Okay, just an example I'll take you. Transmitters are communicating using HART protocol. You must be aware. So HART protocol is taking for a maintenance cycle. So it's not going per se to the SCADA, the DCS actually. So using the HART protocol, you can send the data to a remote center without connecting the DCS. So maintaining the air gap. So there are various design techniques. These are all design aspects to be covered actually. So it is possible to do it, what you told.
Sorry, I will have to break it in. I think we are out of time. Do you want to conclude?
So I don't think we have too much time now. Thank you very much for all the audience, and thank you the panelists. We'll have the next session now. Thank you very much.
Thank you for your time.